Okay. Welcome, everyone. I think we'll get started. Happy Friday. Happy summer, feels like, out there. Welcome, everyone here in the School of Architecture. My name is Blaine Brownell. I'm the director of the School of Architecture in the College of Arts and Architecture here at UNC Charlotte. I want to welcome everyone in the school here, as well as guests. We've got artists and designers who practice here in Charlotte. We've got folks from the airport. We've got folks from the Arts and Science Council here to honor our speaker. Before I introduce our speaker today, I would like to welcome Todd Stewart, who is Vice President of Public Art for the Arts and Science Council, who is sponsoring this event, to say a few words.
All right, thank you so much. Thanks everyone for being here. I am Todd Stewart, Vice President of Public Art with the Arts and Science Council. We administer the 1% for Art ordinance for the city of Charlotte and Mecklenburg County. And through the city of Charlotte, the Charlotte Douglas International Airport, which is how I came to know Benjamin Ball, our fantastic speaker and artist today. I'm so glad to see you all here. It's a real treat to have Ben with us, sharing his process. You know, I don't even know what he's going to talk about. We were talking about it at lunch. I mean, he might go over his whole life story, which would be amazing. So thanks everyone. I'd like to give a special thanks to my colleague, Amina Cooper, who's been managing this project. Benjamin is designing a new sculpture for the Concourse A Phase 2 project at the airport. It's in keeping with a lot of his previous work, but he's tailoring it specifically to us. This is a portion of his community engagement. And yeah, thanks to the School of Architecture for hosting us. And I'm going to turn it back over to Blaine.
Thanks, Todd. All right, thank you so much. I put Todd on the spot here, so he's very, very good public speaker. asked to speak last minute like this, but I appreciate you being here and your sponsorship. I also want to thank Wendy Fishman, who is our Director of Collaborative Works here in the College of Arts and Architecture. Wendy organized this event, and it's one of the many things that she does for us. So I appreciate all of your efforts. Benjamin Ball, I'm super excited to welcome him here. We just figured out it's been since 2005, I think, that we saw each other in person last. Quick bio for Benjamin, because I know he has a lot to show us today, which is I'm looking forward to. Benjamin Ball grew up in Colorado and Iowa. He was significantly influenced by his mother's work in theater, and he studied his degree at Southern California Institute of Architecture, SciArc. And he worked for Frank Gehry, among others. And after graduation, he worked as a set production designer for films, including the Matrix series. So you can already see the multidisciplinary, interdisciplinary, kind of expansive set of interests growing in his career. He also worked in music videos and commercials with such influential directors as Mark Romanek and Tony Scott. His experience ranges from work on the Disney Concert Hall and small residential commissions for boutique firms, complex medical structures, event design, et cetera, et cetera. Great diverse background. In his current collaboration, now for quite a few years, with Gaston Nogues, Ball is exploring the intersection of architecture, art, and product design through physical modeling and the use of digital and more traditional forms of production. Please join me in welcoming Benjamin Ball.
Okay. Oh yeah, this guy's got to go in. Right. Okay. Can we hear me? Okay, great. Thanks, Blaine. That was it's been a while since I've done a talk in actual physical space, and this particular talk is sort of the intersection of several different organizations, School of the Arts and Architecture, or is it the College of Arts and Architecture here, Charlotte Douglas Airport, and Arts and Science Council. So we have several folks from there, all these organizations today who are here. So thank you for coming out and thank you for putting this together, getting me out of Zoom and back into doing talks in what we used to refer to as meet space. So I just called this talk, what did I decide to call it? We're going to call it Design of Production. As Blaine said, let's see if we can, as Blaine said, my studio has in the past been called Ball-Nogues Studio. I'm about to change the name. It is operates as a kind of atelier where we're involved in both the design and the imagining of projects, but also in their production and in their execution. And it's that integration and that conversation that happens between those two sides of things that makes the work what it is. It's a necessary part of it. We are involved in a kind of speculative fabrication processes. So what does that mean? Well, we do a lot of tinkering around the studio, and some of these images are experiments that we've done over the years with various materials. I like to think of this as bringing risk back into the process of fabrication and of making. You know, when you're making Richard Sinnott, who's a craft theorist who I really admire, he outlines how a craftsperson is in direct dialogue with material, and that dialogue involves risk-taking and working with what the material provides to you, whether it's something that you anticipated or didn't anticipate. And he calls that the craftsmanship of risk. And that's what I'm trying to bring in many of these cases to work of an architectural scale, in contrast to the traditional architectural model of making things according to a set of regulations and a set of engineering standards, which have become at this time in history really can be quite stifling. So what you're seeing here are old experiments that we do. The experiments sort of I think of them as you know, kind of harken back to the old proverb of just sink one well deep enough. You know, you do enough of these experiments, something is going to come out of it, which will ultimately become a series of projects. And you'll see some of these images over the course of this talk that will make their way into projects. So it's about developing the means of making things, and the means itself becomes part of the story of the work. And it began 20 years ago, which is when this project called Maximilian Schell was erected in Silver Lake in Los Angeles at a small gallery called Materials and Applications. That's where I met Blaine. And I can still remember that. I think it was maybe 2 or 3 days after we'd put the project up, and I had done this in my spare time when I was working for an architecture firm who does medical office buildings, like outpatient surgery centers, and I was kind of hungry for doing something that involved more risk taking. And so I started working on this project in my spare time using some computational skills that I had developed having gone back to school after like an 8 8-year in that 8-year absence, the whole world had changed. It's like the sea had changed, and the tool set was digital. It was, and not yet parametric, but I started working with parametric modeling software that was designed at that time for mechanical engineering. And that enabled us to explore tiling over tensile structures. And that became, this all sounds very geeky and technical, so I won't spend too much time on it. But what you see there on the left versus the right is where it began, and then ultimately where it led to the PS1 Young Architects program in 2007, sponsored by the Museum of Modern Art. So, you know, it got me thinking. Maximilian Schell, the first project, this yellow thing, big vortex, that formed a kind of social space that was also a contemplative moment in the cityscape. You had this very kind of ecstatic feeling when you entered this space. But it's got me to thinking about craft and about methods of making that at the time, you know, people weren't really using. There wasn't a lot of exploration on the fabrication end of digital design, at least not amongst the little guys. And so I started thinking about, like, can craft become a kind of elite form of knowledge, which it hasn't been traditionally. It comes in and out of being there. But we explored, you know, in those first few years, a lot of different materials, and like I said, sunk a lot of wells. This was with cardboard that was kind of based on our understanding and knowledge of how these Frank Gehry chairs were made, but we're kind of now tweaking them to become more fluid in their form. They were really an attempt to kind of make examples of this integration of computation, computational tools, and the process of making. You couldn't really hire somebody to build these kinds of things for you, because that would immediately put it well out of reach financially. The R&D alone would be huge. So we decided that was going to be our sort of our project with a capital P looking forward. We realized that we were coming from a profession that had a kind of contempt for labor, and that we wanted to move away from that. I always show this slide, which is Brunelleschi's dome in Florence, to introduce the talk. Brunelleschi, if you don't know, you know, he built the most magnificent dome ever constructed in its day, and still remains probably a marvel of engineering and know-how. And it's interesting to note that when he died, he was buried in the Duomo, and his grave site, legend has it, does not say that he was an architect or an engineer. It said he was a maker of machines. And it was the machine, the reversible gear crane that he built, that enabled him to lift stones up to the top of this, whatever, 300-foot dome and make it happen. So he had to be invested in the development of the technology that enabled him to do the projects. And really, the project was the technology, the development of the crane, and then the dome kind of grows out of that. So I'm going to take you through a few different examples of these projects with a capital P, which span over multiple iterations in my career, and then you can just pull me off the stage with a cane, you know, with the hook Todd was talking about, if I just keep going too long. The first is called suspensions, and these were really about working with a basic unit that was variable. These were done this piece was done in 2009, and at the Museum of Contemporary Art, and it was about using a hanging piece of string as a basic building block for creating space. But because a string is so easy to manipulate, easy to work with. There's one piece of information that goes into determining its size, and then two other pieces of information about how it's hung. Is it hung this way or that way? That enables you to explore this idea of variability, non-standard variability in a module very, very economically efficiently in a way that a guy like me who's working out of a garage could do it, with a small team of people. And some of the inspiration came from the Four Seasons in New York, where you can see, that's Philip Johnson. But if you've ever seen the curtains there, it's worth going to this place to see it. I don't think it actually exists anymore, but sadly. But Johnson's curtains were all made of these hanging catenary chains. That's the shape that a chain takes when it's suspended between 2 points. And they just have this magical feeling to them, and they kind of ripple with the movement of the air. At the same time he was doing that, Otto, the Swiss architect and engineer, was working using catenaries as analog computers for him to make thin shell concrete structures. My idea was, can we, rather than using it as a computer or just as a decorative treatment like Johnson was doing, why don't we use it as a way to make space? So we'll expand it out into space to make a kind of aerosol or a kind of gas or a kind of cloud that fills a space with no inside or outside. And in chemistry, you call that a suspension. So this was the first example of that at MoCA. And we used we had to develop technology to do this, and I'm going to show you a little bit about that. But these pieces have this kind of ethereal quality. They feel like you're kind of in contact with something that feels infinite, and something that and something sort of sublime in their kind of diffusion. It's like encountering like a fog rolling into a space. Our challenge with this was to make a space, but also to paint within the array of chain or the array of string gestures, like colored gestures and colored shapes that you could explore as you move through it. And the only way we were going to do that was to make this thing that we called the installator, which enabled us to cut the string, paint the string, measure the string, all from output in a computer, and then catalog the string. The result is a little bit like ECOT, which is it's used throughout the world. It's kind of famously in South Asia, but it's a way of resist dyeing where you pull the yarns out of the loom, dye them in a particular pattern, then put them back into the loom, and the result yields this almost kind of like, to the contemporary eye, they look like kind of like 8-bit computer graphics. And so we started, we don't want to be too geeky about this stuff. You make you make food, but you don't eat the recipe. So we don't want to eat the recipe. So we started thinking about ways in which we could really deliver experience and create a dialogue with history by painting onto this array of string. So this piece is, we mapped this is at the Indianapolis Museum of Art, but we mapped the pattern from a Baroque church onto the string. You see that there on the left, sort of looks like a brain scan, but so wanted to create this conversation with Baroque architecture. Led to a piece called Euphony, and then this piece called Air Garden at Bradley West Terminal LAX, Los Angeles International Airport, this is the first big commission that we got, and we were like, okay, we're going to really need to up our game now because this thing's going to be here for 50 years. So how are we going to make it? We need to make it out of chain. So the airport is a little bit like kind of like a city, and this thing is kind of carved out of the middle of the airport in a space, sort of like Central Park is to New York City. Let me see here, but it's quite a narrow space, quite tall, 80 feet high, 80 feet long, and so our challenge, as I said, was to try to, this is a close-up. We're going to have to, rather than painting onto the string, we're going to have to cut individual segments of chain. So we rounded up our team, programmer, my partner, a now former partner, who's really good with mechanical systems, and we developed this integrated software and hardware system to do it. This is an image of it over the course of 24 hours, but the stripes on the piece represent the projected shadows of the skylight above. So it's kind of a frozen moment in time at the vernal equinox and the summer solstice. And so what you're seeing is sort of where those shadows in theory would land on those two days. And the piece was called Air Garden to sort of kind of complement that idea. Come on, let's change. There we go. Quite a logistical challenge getting the piece up and just figuring out how to keep this thing from tangling is a whole, master's thesis. It's the coloration is based on this principle. We're using, there's a couple things happening. These moire patterns when you see these arrays of catenaries, and this is going to be similar to the project that I'm doing, related to the project that I'm doing here. But then also the blending of cyan, magenta, and yellow, and getting the first order derivative colors, kind of like Ben-Day dots. So you get a whole range of colors out of 4 paint colors. The piece has this kind of, again, let me go back, has this kind of ethereal, you know what? Has this kind of ethereal presence hanging within the space, and it's active. It works when one moves through the space and around it, because it's an entirely different thing depending upon where you're looking at it. It's a little bit like looking at a jellyfish in a marine aquarium, in that the jellyfish is a sort of spatial body, but it's translucent or transparent. So you see the back from all angles. You see the front and you see the back and you see the entire structure of it. And that's really how these pieces work. And we've been we've really evolved the technology and the kinds of forms that they can take, the kinds of stories that they can be in dialogue with. This one is at Iowa State University, and it's actually a model of the tree of life. So each of those segments there it defines a length, and then we translated that into catenaries, and then the catenaries get repeated, and that's where you end up. This is in a biology lab. Boy, this is not very, it's very posterized. Oh, well. That's the piece. In other cases, we've been very bold with the gestures that they make, and this is more related to what we're going to be doing here. This is a piece called Breath Catcher at downtown Los Angeles, in dialogue with some Michael Heitzers you can see down there. I was asking myself, like, how do you have a conversation with such a famous artist, right? Like I wanted the piece to have some kind of conversation with him. So I wish I'd put I don't think I got the reference image, but Heitzer's fascinated with these cuts in the landscape and these scrapes in the landscape. So this thing is like this scrape on the ceiling that's like this bold cut that cuts counter to the grid of the building, cutting through the space. There's it gives you a little bit more of the color blending that you get close up in the morays. We're taking this bigger to the Denver airport as well. So, but it's very different than the one here. This is like 700 feet long. So it's quite elaborate. On to another kind of species of projects. Been working with metal more lately. I wanted to kind of be an architect. This is a piece called Knothole Fence in El Paso. It separates a ballpark from a city street. And I worked with this two ideas. The idea of the knothole gang. If you wait, this is old for me, but kids sneaking a peek into a ball game through a knothole. It's just this kind of corny kind of what's his name, the painter, Norman Rockwell kind of image, and but this is public art, so you got to have that kind of reference, and it's good to have that kind of reference. But then blending that with the ferocity of this thing, and so you end up with these knotholes that are kind of colossal sized, but the fence itself is actually it's one single picket that wraps around the ballpark, and then you can peek inside and see. Based on the design of it is based on this. This is a heat sink, which is used to dissipate heat. An aluminum heat sink inside of a computer. And so we started thinking like, wow, that's got both rigidity, but it also has these really cool lighting effects. And so we start cutting into the back of it and thinking about how we could use it to make a fence, because this has to be a real deal fence. You can't you don't want to push this thing down. You don't want you don't want people can climb it. It's got to be a real security fence. So we extruded aluminum kind of heat sink like components, and then we carved them out using this 4-axis CNC system, and then anodized the whole thing, and then they go up in these panels. But then you can see the grain pattern that runs through the whole piece, around the whole corner, etc. Other works in metal I'm not going to show you a couple other ones that involve reuse of material, but this one I think is interesting in reference to the previous one. This is called Secondhand Geology, and it's commissioned by a university up in Washington State to do a piece at their School of Geosciences and Geophysics, and had been thinking about these. My studio is close to Vernon, California, or Vernon, which is part of LA, which is the industrial part of LA. You see a lot of these bales around there. There's a lot of salvage. They compress bales of material, send it to overseas in many cases to be resmelted into finished steel components. But we decided, like, well, what if we use that baling system to bale cherry-picked pieces of steel? So we started experimenting with using stainless in there and cutting it, working with an aerospace company to cut it. And so this was our first experiment with that. And you can see you get this nice, like, you get the crust on the top, and then you get the surface of the bread on the inside, like if you're cutting a loaf. And we used an opportunity in a gallery to prototype it and to do the first iteration of it. And that's where these are at Edward Cella Gallery, and started exploring finishing it and ideas about book matching. So it's a little bit like it's a little bit like a piece of marble, right? Where you'll slice the marble and open it up and book match it, or wood. So this is made from the same bale, but this is steel tubes, 4-inch diameter steel tubes that have been crushed and then cut. This one's been annealed, and I wanted to take it big and do something structural with it. So we decided we were going to do this piece and stack it like an obelisk. So you just make a basic human form that's got kind of universal meaning, a lot of different meanings. And we engineered it. We're gonna run a big threaded rod, like an inch diameter, down the middle of it, and we're gonna push the whole thing down like a club sandwich to hold it in place. Well, put it up, and that happened. And so it's like the only time I've ever had a panicked call with an engineer. He's like, well, how could we have not, how could we have missed that? It's too soft, So fortunately, you're in Washington, you throw the thing on a truck, you ship it over to Everett, and some people that work for the machine shop that works with Boeing, we were able to kind of rethink the structure of the thing, and bypass the bales with 4 thread rods each in the corner, and make it work. But it was an interesting story. Another material adventure that we've been on over the years is paper pulp. I got real interested in these things. You see them at McDonald's, you see them at Starbucks. The thing on the top is actually a bedpan and disposable bedpan, but it's rigid and it's paper. And sometimes, if it's coated with the right stuff, it can be water resistant. But we started by, like we usually do with experiments. We even started, trying to put seeds into it, so to see if it would grow. We're buying big bales of it. We made blenders that enabled us to blend the paper pulp, the paper down into a kind of gravy that you use to apply to formwork. And that resulted in this series of projects that we called Radiant Body Globs that I decided, like, we got to give these a use. They have to have let's make them into lamps. But so this was kind of my first attempt at figuration. And but you can see what we're doing is building this big kind of stocking that fits over this formwork, but the formwork is soft, so you can pop all of those vinyl balloons, pull it out of the formwork, or pull it out of the stocking, and it's very tight. So you pull it out after you've sprayed paper on it, and it's hardened. But it's absolutely magic, because you just don't expect paper to do this. So these are just shells. There's no supporting structure in them at all. And wanted to take it further. So that led to this, where we, at the Coachella Festival, called Pulp Pavilion. Not very original sounding name, but we had done a couple projects previously at Coachella. I did this with SciArc students, a design build studio a few years ago. This was called the Elastic Plastic Sponge, and it really was like a sponge in that, to get it to make that shape, this is made out of thousands of feet of irrigation tubing, the kind of tubing that's actually in this landscape, because it's a polo field. But we bent it into these shapes, into this kind of soft form structure, that you could then pick up and bend and manipulate with a crane to give it that curved shape. When I don't have a picture of it, but when we made it, it was just laid out like a big ribbon, flat on the ground. So we had experience working in festival environments. I'm not going to get too far into that, but the objective was, let's do this project at Coachella. It's a desert, it's windy, and it only needs to last for 2 weeks. So it's a perfect opportunity to make something out of paper as opposed to steel. You know, it's kind of like buying a cup at Starbucks. You can buy the stainless steel $30 insulated cup with 2 layers of steel, or you can buy a drink in a disposable cup. Well, Coachella's like the disposable cup land of space. So we went about, you know, thinking of ways to scale up and hit upon kind of taking the tensile structures of Maximilian shell that you saw earlier and turning them into these tree-like structures. This meant we needed to test everything on our own. There's no manual, you know, the manual of steel, you know, that engineers use. There's nothing like that for paper pulp sprayed onto jute rope, which is what this is. But the system to do it was pretty fun. In that we had to build a rigid structure to hold the jute rope. And then we kind of wove that structure, we wove jute rope between those rigid boundaries. So there's a rigid boundary at the top. Where is my cursor? Yeah, at the top there, right? And at the bottom. So, and then a truss up the middle, right? So we need to weave over that. But then ultimately the truss is going to be removed. The rigid structure is going to be removed, and we just anchor the thing to the ground. So it's you know, the idea here is to demonstrate that you can make paper work at an architectural scale, albeit for 2 weeks. But it meant a lot of testing. It meant scaling up our production, getting more blenders, and then, you know, developing this whole process of weaving. You know, again, like this is hand work, but it's got to conform to some level of regularity that our engineer defined. So, you know, we got people kind of trying to measure more or less the average distance between these threads, if you will, and then layering up sprayed paper each time over it. And then bringing color into it. We're spraying like one color, you know, we're building up the thickness of the piece, but we're also starting to alternate colors. So we get these kind of color shifts across that are shadowed on one side versus the other of any given surface. It was, got it all out there, got it up, removed the trusses from the top. You can see there on the right that we're about to pull the truss out. And this was the piece. Like everything at Coachella, it's not big enough. But this was when Coachella actually did projects that were more artisanal, and they had people who were making it themselves. Now they've gotten much bigger in their production and have a whole team that engineers and executes them. A few of the pictures. I got about a few more minutes, so I will. Do I? I think I do, right? Okay. Sphere packing, another project. This began with this one. This is called Cradle in Santa Monica. It's on a wall of a building a few blocks from the beach, and it was inspired by this thing and this. These are gazing globes. That's how they're popularly understood. You can see them in gardens, but they're made of stainless steel. I thought, okay, let's get those. The piece uses globes that are packed together. There's a computational kind of sounding term called sphere packing that is really about pouring spheres into a slip mold to give you a kind of surface approximation, and then we weld those together, and then the whole piece transported in its jig to the site, and then the jig is removed, and then voila, you get that. We've moved into some more variations of this, studying knots. So I've done a series of projects that make knots using this series of beads, almost like prayer beads. This one called Weaver's Knot Sheep Bend, and each of the knots reflects something about the culture and the context. This is in Philadelphia, so those knots reference the textile mills that were once along the Delaware River, and the shipping that was there. But these are welded together. A little bit of the form work that goes into making them. It's a little different, but the form work also is a transportation system. So we're welding all these pieces together, and then I'm not going to show any pictures of it going up, but it's kind of fun. We're doing a couple more of those that are bigger, more elaborate. This project is called, you know what? I'm not going to talk about this one. It's too involved. It's one of my favorite projects, but it's going to take too much time. Caged shells. This is a term that I invented because I had to write an academic paper on the one below, and you know, they want descriptions, they want terms, they want theories. It's like, okay, these are called caged shells. But it really is about like the hybrid of a cage and a thin shell thing. There's a kind of a thin shell form. There's a kind of ideal form, and then we're kind of wrapping this cage of steel over it. And this is at Cedars-Sinai Medical Center on the called Healing Pavilion, on the pedestal up above the city. So it's part of a kind of healing environment that was done by Abe Landscape Architects, not to be confused with Hitoshi Blaine. But our piece was an integral part of that, and it grew out of, you know, believe it or not, a production method. This is a CNC tube bender and rolling machine. Oh, it's two pictures of it. Sorry, don't want that. How could you build a cage when you have all these crazy shapes, and they're all it's very complicated to put together? Well, the way you do that is you make 4 details for the whole project. So there's only 4 welds, different types of welds that have to go into this, and it's just about repeating them over and over again. So a lot of analysis that goes into it, a lot of prototyping the most difficult parts of the project first, so that we can learn the limitations of the machine that is making it. These are some of the shop drawings for the prototype, very elaborate. This is the panelization of the piece. It is actually made in panels, but all those panels meet at a miter joint. So you never have to splice a tube together and try to maintain its purity. You're always splicing at a miter, so that there's a decided break. This is a bit of the jigging that we didn't actually produce this, by the way. I don't want to get involved in big time steel production. It's a whole nother game than what I can do at this scale. The piece was oh, let me see if this actually works. It doesn't matter. Yeah, there's the guy. He's applying a thermal spray to it. He's basically applying molten aluminum to the piece. and silicate. The piece was brought over on a big truck, dropped on there, and then dropped into the garden, and then got it up there, and it started to rust. And so I got into a little bit of a legal dispute with the guys who applied the coating, because they didn't put it on well enough. Turns out it's very difficult to spray something like that, right? Because you've got all these undercuts. Todd's a painter, he knows. You ever painted a car or anything complex, and these guys were just kind of not up for the job. So we had to recoat the thing on site next to a, you know, maternity ward, which you can imagine that's 99-page safety book that went into doing that. One of the worst experiences of my life. But we came out, you know, on top. We got the money back. It all worked. But in the piece really functions as a kind of womb out there itself, and a space of repose. And we're moving on to do another piece in this vein, which will be at the Calexico Mexicali port of entry, and we're in the process of doing that right now, with, you know, lots of lessons learned from the previous one. We could either stop here or we could do questions. What do you think? Oh yeah, let's talk about the Charlotte. So this just flipping through more of the cage shell stuff. This was all done in fiberglass. This is a piece we did in fiberglass in for Iowa State University also, but bundled fiberglass, kind of like kind of a bundled rods of fiberglass. So like imagine those tent posts that you use on Nordic tents, kind of bundled together to make this branching system. Really tough. I don't want to work in fiberglass anymore. And carbon fiber. I mean, I'm gonna have somebody else do it. But anyway, so that's the end of that one. We did another one in, let's just, I don't want to go into the slide view, because then I'm afraid this whole technical setup here is gonna fall apart. So I'm just gonna cruise through this. The last piece is one that's called Portrait of a Southern Sky. This is at Thrivent Financial headquarters in Minneapolis, and it's at the top of a 7-story tower. And my aim here was to make a kind of inverted celestial dome, and because it's aiming downwards, it's actually a rendition of the southern sky on the opposite side of the Earth, from Minneapolis. But we worked with a physicist at JPL to do this. It was all done in, I'm just gonna keep going. There it goes. But the piece is entirely fabric. Actually, I should show this. Because, oh, come on. Oh, it didn't work. Let's try this one. All right. Gods have spoken. Okay. This is actually all made of fabric. There's nothing rigid in it at all. It's all hanging kind of catenary shape. And every one of those stars is in a very specific location, 500,000. I worked with a great company that does sequined, you know, like Britney Spears jackets. And they're absolutely amazing. And we mapped the entire, you know, southern celestial dome into these 24 by 18 by 24 panels that then they applied each of these individual reflectors to give you the piece. Anyway, that's it there. In conclusion, I think I'll say, I'm going to show the other piece right after this, but in conclusion, I'd say my work is the evidence of investigations and experiments into making systems of organizing materials and labor into structure and spaces that enhance sensation, generate spectacle, and invite participation. I'm sometimes asked, why do I do this rather than like try to do buildings or, and I often, I heard this quote that's, I think it was Chopin who said, a fan asked him, why did nocturnes and not opera or symphony? And he replied, Madame, my kingdom is small, but I am king there. So this is the piece we're going to be doing in Charlotte. We are in the process of building this. This is a pieces in the suspension series. It's the first of its kind to use to have this kind of big gesture that is almost like an individual sculpture. The other pieces have been sort of more like installations. They're spaces that you can inhabit. This is really more like a very big object, but not an object in that it like the other suspensions, it's neither solid nor void. I wanted it to have the flavor of the kind of heroic, modern, macho gestures that were done in the middle of the 20th century at airports, a la the TWA terminal by Saarinen, Dulles, the Gateway Arch, this kind of swooping language, which is meant to evoke flight and possibility and optimism. But in this case, it's all transparent in 4 colors. So it's mostly air. And with that, I'll stop. Thanks.
I'm really kind of curious about how you kind of go about kind of expanding your processes and literacies and your material literacies, because you can see in a lot of the things that you can imagine. Well, you found some materials that you kind of that you kind of interrogated and insight about some pretty sophisticated high-tech technologies that are being put in service of executing your projects. And I'm just kind of interested to hear how you simultaneously discover new technologies that allow you to kind of make sophisticated things while you're also doing things really from low ground.
Mm-hmm. Yeah. Well, the technology that, well, okay, first of all, I have my view of technology is that I think you're talking about digital, but it also, for me, it extends into the technology of the knowledge of organizing a whole studio to build something, and how do you orchestrate all those hands to put something together. So that's another kind of technology, but how do you put the digital technology into the service of that technology? Truth be told, I mean, most of these projects are done using parametric modeling systems, and that was sort of where I kind of built a name for myself in the beginning. And while they don't take the same form, they still are about part-to-whole relationships and unitization of big structures, whether the unit is a catenary chain or a tile or a rolled piece of tubing. The logic is one of a component that can be manipulated within the parameters of the tool that we've chosen to use, and it can be and we can build that parameter, that limit, into our modeling systems, and then we have a sufficient output system to execute it. Sometimes those outputs are direct to digital, like the very first project, Maximilian Schell, actually the oldest one. Other times the machine will bend the tube like you saw in the healing pavilion, and then we have to wrestle with it over a jig, but that's just the nature of steel, right? Like you're never going to build anything out of steel and weld it and expect everything to work exactly like it did in the computer, because it's so it springs back. There's stuff you can't predict with what's going to happen when you weld a whole area of it. You encounter all kinds of issues. So I don't know if there's a how to do that, but I think that the digital technology has been more or less in the same family since the beginning. And so yet the materials are very different. And it's just, us looking at materials through me looking at materials through the lens of how could we unitize this, and how could we make something structural and big and of scale with this? And it usually comes from a material insight versus a computational one. Now I'm working with we're starting to do some stuff with Houdini, and we're starting to work with more figural stuff. So it's starting to change a lot, but for the most part, it is conceived with from the material to the digital. The shape is never determined until we put it in the computer. But we have to find a candidate which can be systematized. Does that make sense? I don't know.
Also been thinking about your process, how there might be a general assumption that for architects and artists that this should come your way to start fresh. What should this be? But in reality, is that for the last fight, it's moving in margins, right? Or sequentially.
Yes. Yeah.
How do you organize?
Yeah, I try to use opportunities. We're always R&Ding something. I mean, I've had to design the studio in such a way that we can. You got to pay for that, right? Like it costs money. So I've used the example of like the way that Warhol Studio operated. I don't know if it's great, but it might help explain. I mean, Warhol did portraits, right? He did portraits. He got paid really well to do portraits, and then he used those portraits to research. He to do the films, and the films were sort of viewed as avant-garde, right? The portraits, the graphic design, that kind of stuff was a little more mainstream, and it utilized the production methods that he had developed, 10 years prior. So that's sort of the way I have to think about it and structure things. Not to say that anything that I'm doing is inexpensive to produce by no means, but there are things that I can predictably say, I can do this for this much money. And that funds some of that in the downtime we're working on other exploratory stuff. But if you remember those images that I showed at the beginning, all of that tinkering really is what primes the pump and enables us to see possibilities when we have a new opportunity for a new commission, and we want to try a new material. So we have the pump has hopefully been primed with some experiments. We're also always going on tours of you know, one of the good things about living in LA and LA County is you got a lot of aerospace and, you know, entertainment, what boats, whatever. There's a lot of people making stuff, so you can see what's happening in their studios and art as well. And you can see how they're doing stuff, and that helps prime the pump too. But I try to keep, and I've fallen out of that before. I've really gotten into a rut, and then I was like, get an opportunity to do something. I was like, I don't have any ideas, you know. So it's really essential that we are tinkering all the time with something.
When selecting material like string or paper pulp, there's infinite amount of manipulation that you can do with these materials. How do you narrow down your pulpal selections?
Mhm. That's a great question. That's well, this one, for example, I let the space do the talking. I let the structural opportunities that are inherent in the space hopefully provide answers. So, you know, the shape of this piece is to some degree determined by the locations of the beams in the ceiling, and that's where the rigid structure is that's where the fertile structure is, you know, to work with in the building, to hang something. And so, you know, we identified those opportunities and like, okay, how could we work, how could we minimize the amount of connections? And we're like, okay, if we minimize the amount of we minimize connections, that means we have to have cables that are the primary structure hanging between 4 points. The minimum amount of connections for a project like this you could probably make to the ceiling is 4. How do we, so that kind of determines that we need to have these big swooping cables. And it just kind of goes from, it happens from there, you know. In the case of paper, the Pulp Pavilion at Coachella, the reason it's that shape, you know, we were given the requirement that it provide shade. So on one hand, this kind of tree shape makes sense, but also that shape, when I showed the first images of it, of the process, you know, that's to weave a network of jute rope like we did, and to make that network tight, like rigid, like every piece of jute in that network is tight. There's nothing loose or floppy about it. To do that type of shape, which is like a catenoid shape in, I think in engineering speak, is inherently allows you to make a tight matrix of rope in it. That's a really very long and technical explanation to something that is should be pretty simple, but it's both. It's both. There's not that many. There's only a limited vocabulary of shapes that you can make at that scale with paper, using that technique, and that was one of them. And it happened to be, or we chose it because it could make a tree, a forest.
Hi, my name is Joseph. I'm a first year student. This semester I'm taking an airport planning course with the Chief Infrastructure Officer, Dr. Stina.
Mhm.
And we're looking up to go on for Ball-Nogues Studio about a month and a half ago of
Mhm.
this space.
Mhm.
They didn't tell us about this being there, so this case, that case was kind of boring before. I know there's people there for here, sorry, but it was kind of boring before. This makes it really cool. But one of the things we're talking about that also wasn't there yet, at the very beginning of the space coming from phase 1,
Yeah.
down all the way to phase 2.
Yeah.
As soon as you turn the corner of that space, there's going to be a salvaged tail from the McDonnell Douglas aircraft.
Mhm.
I've noticed that this also follows in the center, a long ways in the center, of the structure, so it's pretty parallel that to go. Was that something that you knew about and planned on, or was that kind of just coincidence that both structures are gonna be parallel to them?
Well, yeah, I mean, I was given this space, right? Well, this is, truth be told, we've actually moved it, but it's in a very, very similar space. They're essentially the same space with a few differences. But so I didn't choose the space. So when the airport commissions the piece, they come to us and present us with a space, present us with a budget, show us what you can do with this budget in this space, and so I'm not really part of the process of choosing. Sometimes I am. So in this case, though, the shape is really, I'm trying to create as much impact and presence of the piece as I can in that space. And so I'm, kind of pushing at the envelope of the side of the edges of the space. It's like I think one point we were discussing like the whale at the Natural Science Museum in New York City, that you walk in this space and it's boom, this huge whale that fills the entirety of the space. So that's kind of what we were after with this. Although this piece isn't solid, so it's going to have a different kind of presence, but I did want it to be big and pushing at the seams.